All right. Forgive the change of scenery on the other side of town when this is being recorded. I'm in a friend's office and have a few minutes to hurry up and sneak this in there, get 8.2 recorded for you. So I want to do some work and get it in there while I can. 8.2 coral reefs, what we're going to be looking at today. Remember, Unit 8 is all about different marine ecosystems. So we're going to focus on coral reef ecosystems for today. The first thing that we want you to know, remember you are writing the bold in your study guide as you follow along. Two broad categories of coral. You've got hermatypic coral and ahermatypic. Your hermatypic are what we would consider reef builders, what you normally think of when you think of a coral reef. These are able to be reef builders and able to create an entire ecosystem around them, largely because they contain what are called zooxanthellae. These are an algae, a symbiotic photosynthetic dinoflagellates. They're an algae that lives in a symbiotic relationship with the polyps that make up the coral. The polyps join together, attach to a hard substrate, join together, put a kind of a calcium crust around themselves, and then within that crust, these algae live in there with the polyp. And so it's a very, very important symbiotic relationship. They need each other. The polyp, when it excretes, it feeds the algae, and then the algae provide a food source for the polyp, and it kind of goes round and round. And we'll talk more about that as we go. And we also have our ahermatypic corals. These do not build reefs. They may not contain a zooxanthellae, and they can be found in colder, deeper waters. All right, so coral are cnidarians, and really I would prefer that this not say coral are cnidarians, really polyps are cnidarians. So they're basically like tiny jellyfish, or a Medusa jellyfish has the tentacles facing down, or a polyp has the tentacles facing upward. But these have stinging cells or nematocysts on their tentacles, and they come together to form a coral. The coral itself is not a cnidarian, the polyps within it are. So the coral polyp secretes a calcium carbonate skeleton. That's what we look at when we see a coral reef. What we're looking at is a calcium carbonate shell, basically skeleton, an exoskeleton that the polyps create around themselves. And most reef building corals are colonial, meaning they want to live together in large groups with similar types. Coral colonies can come in a variety of shapes and sizes. They can be tall and branching. This tends to be more common in shallow waters. They can be flatter, which tends to be more common in deep and colder waters. Some of the common shapes that you can find for a coral include plate-like, leaf-like, columnar, meaning like a column, massive, meaning just in a large mass, and then branching. I'll give you an image of what each of those look like. Please have each of these written down. So you have your plate-like here. You can see why they would call them that. Your columnar, they just rise up in columns. Your massive is a large mass, and your branching tend to look like kind of like antlers, maybe, in the way that the branches come off of the main column. Coral nutrition. Zooxanthellae help in the deposition of the calcium carbonate skeleton. Or the part that we want you to write here is that the coral polyps can ingest plankton and other small prey aided by the nematocysts, or stinging cells in their tentacles. They kind of pop out of the skeleton, or hold tentacles out of the skeleton, and something comes by and they grab it and can pull it in and eat it. A couple different techniques in how it can work. They ingest plankton and then sometimes small other small organisms. Let's see. I want to keep on going, not take up too much of your time here. Let's get to here. Conditions for growth for reef building corals, there are a couple of things that have to be in place in order for a reef to be able to grow. There needs to be a hard substrate. We've talked about before, kind of a term for like a rock surface, not always rock, but for a reef, it almost always is. That first polyp gets there, settles, and a colony starts to form around it. You've got to have optimal light, or the zooxanthellae that live with the polyp. It is a primary producer. It's an algae, a plant that needs to perform photosynthesis. So you've got to have light in order for that to be able to happen. Very narrow temperature range. Can't be too hot, can't be too cold. Has to stay relatively close to the same temperature year round with no big swings. Narrow salinity range as well. And then we don't want you to know that it does require low pollution levels. It's something that we suspect is already a problem and will continue to be one in the future. This just builds off of some of that reef building. They tolerate low temperature range compared to most marine organisms. Let's see. I'm going to jump down here. Coral stress can lead to bleaching, which is the expulsion of zooxanthellae. That's not in bold, but I would actually like for you to go ahead and write that down. We want to make sure that you know what bleaching is, so please include that on your study guide. That bleaching is the expulsion of zooxanthellae from the coral polyp, and this makes it lose its color, turns the coral white, which is why it's referred to as coral bleaching. It's a big problem right now throughout the world with coral bleaching that is taking place, so we'll mention it again in a moment. Just an image here of where some reefs can be found throughout the world. So other events beyond just high temperatures can cause coral bleaching. That's one of the main concerns as temperature rises, that coral bleaching is taking place, but poor water quality, too much sediment building up in the area, wave stress can be a problem too. A number of different things that can cause this coral bleaching that are very, very concerning right now. We noticed that that coral requires a low salinity for growth. I mean, it's not going to grow where there's lots of fresh water. It's a very narrow. Actually, it needs a pretty high salinity, but it's a very narrow window. Not too much salt, and you can't have not enough salt. You got to have just the right amount. Kind of a Goldilocks sort of situation there. Conditions for growth. So just again to reiterate, we said this already, but this is very, very important. Even low levels of pollution can kill coral polyps. So high nutrient levels due to runoff can also allow seaweed to take over too. We're talking about nutrients. We're talking about like runoff from fertilizers, phosphates, and nitrogens, and that kind of thing that can actually help these things grow. The things that we put into our lawns help our grass grow and look good. It also helps seaweeds and algae to grow as well. And so when it all runs off into the ocean, it can be a problem, can disturb the balance of what nature had done. We're going to look at 3 different types of reefs. Your first is a fringing reef. It's the simplest and most common reef form. It's a narrow strip of reef along the shoreline. So an image here. So this is going to be this area is a reef along the shoreline. A fringing reef is right up close to the shore. Then you have a barrier reef. This is going to develop close to the coastline, but a little bit farther offshore. So typically, always a barrier reef is going to end up with a lagoon between where the shore is and where the reef is. There's an area between the two. It's not right off the shore like in a fringing reef. Here's an image of what that can look like. You see your shoreline here, your reef here, with a lagoon between the two, referred to as a barrier reef for the barrier that it creates. Storms and waves and tides come in. The Great Barrier Reef is a classic example of that. Let's see here. The next type is atolls. We've mentioned this earlier in the year as one of our seafloor formations. An atoll it's a circular reef surrounding a central lagoon. And that lagoon gets there. This used to be a mountain, right? This used to come up out of the water. Formed by a volcano, rose enough up out of the water, a reef formed around it, and then over time, over millions of years, the mountain erodes, and you end up with a lagoon in the middle and a reef surrounding what used to be that mountain. So the reef forms as a fringing reef, but over time the mountain erodes, and you end up with an atoll that gets formed. And again, this is what we just said. The coral begins as a fringing reef around a newly formed island. Over time, weathering erodes the island, leaving that sort of circular atoll reef formation. Another image over time of how it would work. Coral reef ecology. Coral reefs are among the most biodiverse ecosystems on Earth. We want you to know that there's lots and lots of life in these coral reef ecosystems, and so it's definitely a major concern for biodiversity to see that our coral reefs are bleaching and that a lot of these species may be in jeopardy. The food web is basically based around zooxanthellae. There has to be a primary producer at the bottom of any food web. You've got to have something that's performing photosynthesis, or in rare cases, chemosynthesis. And so here in our coral reef system is primarily going to be our zooxanthellae that form the base of that food chain, our food web. Keep it moving here. An image here of some of how that might look like. Lots of different organisms that live there that all rely on each other, and then more of a food web kind of demonstration of what it might look like with the zooxanthellae, and then some seaweeds and other algae that might be at the bottom, and then from there working your way up all the way to top predators like some sharks that may live around a reef system. There is competition on the reef system with other species that live there, but also first we mentioned competition that exists there with the corals themselves. They are competing for space and for light, and so they have the ability to sting each other, and so they sometimes will. Corals will sting one another if they contact each other, and that can be part of their way of fighting for that space, producing kind of a toxic or a foul-tasting chemical. Common in soft corals. Sponges can kind of do the same. An image of how that might look. This coral is stinging this coral in order to fight it off as they fight for space. And then there's just noting that there's lots of other competition taking place there too, between fishes, mollusks, crustaceans, lots of other. There's so much biodiversity there. And anytime that's going to be the case, there's going to be lots of competition taking place also. We think about coral reefs as these beautiful, peaceful places, and they are for us, I guess. But there's certainly tons and tons of competition that is taking place within a community like this. And then we'll mention here too, grazers are one of the very helpful organisms within a coral reef ecosystem. Certain fish and sea urchins that help keep the seaweed from taking over. They eat away at the seaweed, and so it keeps them at bay in order to make sure that the coral are not beaten out in that competition for space and light. Image there of a crown of thorns. And then just note, you don't have to write this down. So some other symbiotic relationships that take place throughout a coral reef, but really we want you to focus on the polyp and the zooxanthellae that form the coral itself. Just be aware of that symbiotic relationship, and that should have you good to go. I'm not sure why we end the show with this, but here's a giant clam. All right. So there's 8.2 coral reef system. We'd love to spend so much more time going more in depth about this particular marine ecosystem, but it is what it is. We get one day to run through the notes, and then we'll use the rest of the week to build off of this information a little bit and give you some more visuals and what this kind of stuff looks like, etc. There's your 8.2. Hope you have a great week. Peace.